In this walkthrough, I am going to show you how you can set up Arduino IDE for ESP8266 development. The intermediate checkpoint is DumbDisplay Blink Test via Wi-Fi. Finally, I will show you how to program a very simple interactive LED grid on DumbDisplay. This walkthrough assumes that you have already installed Arduino IDE and DumbDisplay Arduino library. If not, you may want to watch my previous video illustrating how to do exactly that. ESP8266 development with Arduino IDE is just like development for Arduino Uno. But you have to set your Arduino IDE up, adding ESP8266 as a target development board. First, select the menu, File, Preference. On the displayed dialog shown, you should see the input box labeled Additional Boards Manager URLs. Switch to your browser and browse to ESP8266 GitHub web page, and find out the URL for the ESP8266 Board Manager. Copy the Board Manager URL as shown. Go back to Arduino IDE, paste the copied URL to the input box. Press OK. You are almost ready. Now select the menu, Tools, Board Manager. In the search box of the dialog displayed, input ESP8266. An item to install the ESP8266 board should be shown. Click on the Install button on the item. Wait until the installation finishes. To confirm that ESP8266 can now be selected as target board, go to the menu, Tools, Boards. You should see the sub-menu ESP8266 Boards. That's it. You are now ready to start developing for ESP8266. You certainly need to tell Arduino IDE that you are going to develop for it. Select the menu Tools, Board, ESP8266 Boards. Select the board of your ESP8266, say Node MCU. Next you will need to select Port. Select the menu Port. Usually, Arduino IDE will show you the port of your ESP8266. Next I will show you how to modify the DDBlink example to be using ESP8266 Wi-Fi to connect to DumbDisplay. After opening the example, save a copy of it, say, as Wi-Fi DDBlink. Now you can make modifications to the sketch without messing up the original. The first modification you make is to define the macro DD for ESP8266. Next you will change the include from SS DumbDisplay to Wi-Fi DumbDisplay. Finally you will change the DumbDisplay argument to something else as shown. Three pieces of information are needed. First, your Wi-Fi's SSID, the password to access your Wi-Fi, and the port to use for Wi-Fi connection, which is default to 10201. Actually, ESP8266 will be acting as server that DumbDisplay will connect to as client. Don't worry, the needed modifications will be on the description below this video. Now, you are ready to upload the sketch to your ESP8266. One important piece of information is the host IP of your ESP8266. In fact, while your program is waiting for connection, log messages will be written to the serial port with baud rate 118,200. Go to Tool, Serial Monitor, to bring up the serial monitor. From it, you should see the host IP and port your ESP8266 server is listening on. Write down the host IP. You will need to enter this piece of information to your DumbDisplay app in order to actually make connection. Now I will show you how to program a very simple interactive LED grid of 50 LED that will toggle state when touched. Line 1 and 2 include Wi-Fi DumbDisplay library. Line 4 defines DumbDisplay object, which is to use Wi-Fi to connect to DumbDisplay app. Line 5 declares a LED layer, which will be created in the setup block. In the setup block, line 9 creates a LED grid layer with 10 columns by 5 rows of LED. Line 11 set up the LED to be light gray when the LED in off state. Line 13 enable the feedback mechanism. In the loop block, line 18 and 19 poll and check to see if there is any feedback needs be handled. Line 21 handles any feedback got and toggle the LED click. Have fun with DumbDisplay. May God bless you.